Hello, and this is the third video uh, for dilutions. This video we're going to talk about how to calculate how much to use in your dilution. So before we went over the dilutions, concentrations, and the stock solution. So now we're going to figure out exactly how to do the math for exactly how much ingredients to use in your dilution so you get the desired amount. In our previous video, just to review a little bit, we learned that a stock is a highly concentrated solution. So a stock is just another solution. It's just highly concentrated, made by adding the ingredient, whatever your active ingredient or your desired ingredient is, to a small amount of water. And we used the example of orange juice concentrate, the frozen orange juice in a can that you have to add more water to in order to get orange juice that you drink. That orange juice concentrate is a stock solution. It has mostly orange juice, but it does have a little bit of water in it. But then you have to take that stock solution, that orange juice concentrate, put it in a pitcher, and then add more water to it until you get the dilution, which is what we know as orange juice. Now, a dilution, number two, a dilution is another solution, just like a stock is a solution, but a dilution is a solution made by watering down the stock solution. So just like that orange juice concentrate is the stock solution, and you water it down until you get orange juice that you can drink, and that would be the dilution. And you write down the dilution if you want to find out the fraction of how much you need to dilute something by, or how much you've diluted something by. You write down the amount of stock used, the amount of the stock solution used, over the total volume of the solution of your final result, your dilution. Number three, a concentration. We've gone through stock solution, a dilution, and now we're on to a concentration. Is the amount of the original ingredient in your dilution. So that original or that concentrate, that OJ concentrate, which is the stock solution, has mostly orange juice in it and then a little bit of water. And then we water it down to make drinkable orange juice. So we want to know exactly how much of that original orange juice, just the pure orange juice from the stock solution, is in the dilution. And you write that down by the amount of the ingredient, that would be the pure orange juice in this case, over the total volume of your dilution or your final result of your solution. So if you notice here, the total volume of, or in the under dilution, you want to use the amount of stock over the total volume of your solution, and this should be final solution or dilution. Your end result. So the total volume of solution. Now, if you notice down here in for concentration, you also put that over the exact same thing, your total volume of solution. So the end result. And that's in volume, so that's going to be in like liters or milliliters, something like that. It can be either one. Now C1V1 equals C2V2. This video is going to be all about this formula right here. We're going to determine how to make a dilution from the stock solution, just like how to make orange juice from the frozen orange juice concentrate in a can. So you want to mix the correct amount of stock solution in a little bit of water, and then you just fill the rest up with the rest of the way with water until you achieve your desired volume. And when I say water, you can also put in place there are some other diluents. It's just we use water in these examples because water is the most used when we make solutions in the chemistry lab. So I just say water, but really the technical term for what you mix in with it is called a diluent. But I just use water. So there's no need to measure the water. because you're measuring, you have the other measurements. You're measuring the stock solution that you're putting in, and then you know what the final result, what the final volume needs to be. So you put the stock solution in, and then you just fill it up the rest of the way with the water. So you don't need to measure the water, you just fill it up. Like say you're making a liter of a dilution. You would put whatever the amount of stock solution is that you need into it, and then you just fill the rest of the way up with water until you hit the liter marker. You must know the correct measurement of the needed stock solution. You do need to know this, the amount of the stock solution you need to use, and you need to know the final volume desired. So if you need to make a liter of a dilution, then the liter would be the final volume desired. So C1V1 equals C2V2. This formula is what we use to calculate how much stock solution to use, and by its concentration. And the like the original in the ones right here, the ones for the C1V1, C1V1. The ones mean we're referring to the original stock solution. So C would be its concentration, and V would be the volume in like either liters or milliliters, something like that. You could also do microliters, nanoliters, you know, just some liters is usually what we use. And then the number 2 is what we use for the new dilution that we're going to make on the right hand side of the equal sign here. So the concentration of the new dilution that we want to make and the volume of the new dilution that we want to make. So as you can see down here, I have it written out. The concentration of your stock solution, that would be C1, times the volume of your stock solution, that would be V1, equals the concentration of your dilution, that's C2, times the volume of the dilution, that's V2. Now a concentration, this is usually we've been doing before in the videos, we were writing concentrations in this format, milligrams over milliliters, or grams over milliliters. It should be grams over milliliters. It's a lot easier when you do it that way. So grams over milliliters, or milligrams over milliliters, it just depends. So that's how we've been writing concentrations before. So we could have like 15 grams of hydroxide. I don't know if this is a real thing. I'm just pulling things out of the air. Over 1 liter. So that would be a concentration. Or you could write it in milliliters, 15 grams over 1,000 milliliters. So that's the way to write concentrations. That's how we were writing them in the previous video. But actually concentrations can be written in several different formats. Like there's percentage, you can write it in percentages, and that just means you divide the grams over milliliters and you take it times 100%. So if you have 15 grams over 1,000 milliliters, let's see, get out the handy calculator, 15 grams over 1,000 milliliters, that would be 0.15, and you take it times 100%, that would be 15%. Oh, I'm sorry, 0.015, I knew that was wrong, 0.015 times 100% equals 1.5%. Excuse me, if you thought that was wrong before, congratulations, you're paying attention. So, bad. All right. Now, also another way to write concentration is you can write the the ingredient's molarity in the stock solution. And molarity doesn't change with the amount of stock that you use. It's always that same molarity. So a molarity is how many moles of the ingredient per liter of solution. So you could have 5, if you have a 5 molarity, that means 5 moles every liter. If you have 25 molarity, then you'll have 25 moles per liter of solution. So even if you take just a teaspoon of that stock solution out, it's still going to have a 25 moles molarity because you're calculating the molarity based on how much is in a liter of the solution, always. Also, you could have a number x, which is like if you have like 5x, 25x, something like that, 100x. If you see that, that is a form, that is a way to write a concentration, and that's just how many times it's concentrated more than normal, more than what you're going to need. So usually that means when you're diluting these, when it comes down to x's, you're going to want to dilute it down until it's 1x. That would be the concentration in your dilution. Not all the time, but a lot of times. Now let's see an example so you can see what I'm talking about. See, you have, let's say you have a stock solution with a concentration of 50% of the ingredient. So 50% of the stock solution is your actual ingredient, your original ingredient. Now, how did we get that 50%? Remember, we took the grams and divided it by milliliters times 100%. So if we have 50 grams of an ingredient, if we have 50 grams of an ingredient in 100 milliliters of stock, then that's going to equal 0.5. And you take that times 100%, and that is 50%. So something like that. So we have a stock solution with 50% concentration. Now we take 10 milliliters of that stock, of that 50% stock, and add water until it measures 1 liter. So 1 liter would be the new dilution. That would be the volume of the new dilution. So that would be V2. Now this stock solution with a concentration of 50% ingredient, that's the concentration of the stock solution. So that would be C1. C is concentration and 1 is for the stock. And see, that's the one right up here. You take 10 milliliters of the stock, so that's the volume of the stock. So that would be V1. That's V1 right there. So we have C1 is 50%, V1 is 10 milliliters, and then we added water until it measures 1 liter, that's V2, so 1 liter of the new dilution. So the question is, what's the concentration of the new dilution? So the concentration of the new dilution would be 0.5%. So that would be C2. That's the concentration of solution number 2, the new one. So that's 0.5%. As you can see, I wrote it down here nice and neat. So 50% times 10 milliliters, that's from the stock, equals 0.5% of 1,000 milliliters. That's the new solution, the new dilution. And of course, I have 1,000 milliliters down here because 1,000 milliliters is the same thing as 1 liter. I just put it down in 1,000 milliliters down here. Now that we know the variables used in the formula, we can see how that formula works. We can determine the amount of the concentration or the volume of the solution or the volume of the stock solution. We can determine any one of these things as long as we have the other three. So let's try some problems. Now here's one. If we have 10 milliliters of a 50% solution, here we go, 10 milliliters of a 50% solution, and we dilute it to 0.5%, so that would be the concentration. What is the total volume of the dilution? Now the dilution is it number 1 or number 2? That's right, it's number 2. The dilution would be number 2, the stock solution would be number 1. So let's write all these numbers down here. If we have 10 milliliters of a 50% solution, and we dilute it to 0.5%, what is the total volume of the dilution? Here's another one. If we have 10 milliliters of a 50% solution, so this is the same stock, and we dilute it to a final volume of 1 liter, what is the concentration of that dilution? So here would be C2 right here. Here's the concentration. Here's V2, here's V1, and here's C1. So we need to find out what C2 is. But look at this. Over here we have 10 milliliters for V1, but over here for V2 we have 1 liter. Now these have to match up. It has to either be milliliters for both of them or liters for both of them. You can't mix and match. It has to be the same. It can be either one. That's fine. You could have milliliters, you could have microliters, you could have nanoliters, you could have just plain old liters. It doesn't matter. But what matters is that they're both the same. They both have to be in the same format. So we got to take this 1 liter, and 1 liter is the same thing as 1,000 milliliters. So we're going to rewrite this on the next screen in 1,000 milliliters, so the milliliters will match up with the milliliters of V1. Now see, we have it all nice and neat down here. 1,000 milliliters is the V2, and we don't know what the C2 is. That's what we need to find out. And over here is your stock solution. The 50% is your C1, and the 10 milliliters is your V1. That's the amount of stock solution you're going to take out and mix with water. So now we can solve this. Now that we have the milliliters matching, now we can solve this. So we have 50% times 10 milliliters equals, we don't know, percent, times 1,000 milliliters. So 50 times 10 is 500% times milliliters, and it's equal to, we don't know, percent times 1,000 milliliters. So we have to divide this by 1,000 milliliters so they cancel out, and so we have to divide this by 1,000 milliliters. The milliliters cancel out, and 500 divided by 1,000 is 0.5. And you carry that percent down. See the percentages left over? So we know this is going to be a percent. So 0.5% is what the dilution concentration is after we make it, after we take the 50%, 10 mils of the 50% stock solution and add water to it until we get 1,000 milliliters. The concentration would be 0.5%. So let's do another one. If we have a 50% solution and we need a 500 mils dilution, that would be your V2, at 0.5% concentration, how much stock should we use? So now it's just a matter of math. So we got 50% times we don't know milliliters equals 0.5% times 500 milliliters. So this would be 250% times milliliters. And this over here, we don't know, so we need to divide this by 50% to cancel these out. And we'll divide this by 50%. The percent sign cancels out. And 250 divided by 50 is going to be 5. And we have milliliters left over here, so that goes over here, milliliters. So 5 milliliters. We're going to need 5 milliliters of that original stock solution at 50% concentration, put it into a pitcher or put it into a graduated cylinder, and then fill the rest up to the 500 mils level to get the 0.5% concentration in your new dilution. So let's try this one. If we made a 500 mils dilution at 0.5% concentration using 25 mils of the stock solution, what was the concentration of the original stock? So see, we're looking for something else here, but we still can use this formula just like we were doing for finding the volume. So we have we don't know percent times 25 mils equals 0.5% times 500 mils. So 0.5% times 500 mils is 250% times mils. And we don't know over here, so we have to divide this whole thing by 25 mils. That is cancel out. Divide this by 25 mils, because what you do on one side, you have to do on the other side. These milliliters cancel out. And then 250 divided by 25 is 10%, because this percent sign is left over, so you bring it over here. So that's 10%. Now here's another one. If you need to make 1 liter of a 1 times dilution. Now remember, I told you concentrations can be written in different ways. Up until now we've been using percentages, but if you see a number with an X after it, that is also a form of a concentration. And you don't need to be able to break down what this 1X is. You just have to be sure both if this concentration of the dilution is 1X, you have to make sure that this other concentration of the stock solution is also in a number X. It has to be the same units of measurement. So as long as you make sure it's the same units of measurement, it's fine. So if you need to make a 1 liter of a 1X dilution from a 5X stock solution, how much stock solution do you need to use? Well, what do we have? We have a 5X stock solution. That's C1. The concentration of the solution of the stock solution is C1. That's 5X times we don't know how many liters, equals, we need a 1x dilution, and how much of this 1x dilution do we need? We need 1 liter. So let's multiply these together. So that's 1 x times L, and then over here we have 5x times we don't know L. So we need to divide by the 5 times 5. This isn't 5x like in algebra. This is just, the x is not representative of a number. That's just saying that it's 5 times concentrated. So the 5 times cancel out. What we do on one side, we have to do to the other side. So this x cancels out with this x up here, and you end up with 0.20 liters. So how much stock solution do you need to use? 0.20 liters. So that's also the same thing as 200 milliliters. Now you could have changed these liters into milliliters. We could have taken that 1 liter and changed it into 1,000 milliliters, and you could have done the math that way, and you would have come out with 200 milliliters. Just make sure, as long as you make sure that if there's liters on one side, there has to be liters on the other side. If there's milliliters on one side, there has to be milliliters on the other side, and so on. All right, here's another one. If you need to make 1 liter of a 5 molar dilution, now we're going to use molars, molarity. Remember, this is another way to write concentration, is molarity. And big M after the number means the number of moles per liter of solution. Now this liter does not change. It's always the number of moles per liter. It doesn't matter if you're using a liter or not, just the measurement for molarity is the number of moles per liter in the solution. So in this 5M dilution that you want to make is going to have 5 moles per liter of the dilution. It doesn't matter how much dilution you want to make. It's the measurement itself, the molarity, is 5 moles per liter. So if you need to make 5 mole dilution, 1 liter of a 5 molar dilution, that's the C2 and V2, so we're going to put it on the right side over here of this equal sign. So we have 5 molarity and 1 liter. Okay, from a 10 molarity stock solution, so that's going to be over here, that's your C1, 10 molarity. How much stock solution do you need to have? And so see, I put question mark liters. Why? Because over here is liters. So we just want to make sure these match up. So if we take 5 times 1, 5 molarity times 1 liter, we have 5 molarity times liter. And over here we have 10 molarity times, we don't know how many liters. So we have to divide this by 10 molarity. So they cancel out. And what we do on one side, we have to do on the other side. So we divide this by 10 molarity. That molarity sign cancels out. And then 5 divided by 10 is 0.5 liters, because we have this liter sign left over. So we're going to bring that over. So how much of the original stock solution do we need to use? We need to use 0.5 liters of a 10 molarity stock solution. 0.5 liters or 500 milliliters. Same thing.